So you want to learn how to evaluate complex limits, or more complex ones. These aren't the most complex, but calculus 1. In this one, we're given a function h, and we're given this weird looking graph, and actually there's multiple things going on. You're getting one limit approaching this way, one limit approaching this way, you get another limit approaching this way, and it gets pretty wild. So we're going to go one by one through each question. So over here it's asking, as x approaches -3, what is the y? And if we look over here, this is where -3 would be. And since it's approaching it from the left over here, the value is going to be 4. And then over here, it's asking the same thing. It's asking us, but instead it's approaching from the right, and the value is also 4. The reason why the value is not something like do not exist, even though there's a hole here, is because it's only asking for the right limit, and this one's only asking for the left limit. It's not asking for the limit overall. But even if it did ask for the limit overall, it would still equal 4. The reason why is because both limits technically still approach here. There's no gap in the lines. It's just a hole. But then if you look at D over here, the answer is actually does not exist. And the reason why is because it wants you to evaluate it at the exact point, not at the limit what it's approaching, but at the exact point. And at that exact point, there's a hole, so it doesn't exist here in this account. You know, every time you see this, think of it as something that's evaluating the exact point, and think of these as evaluating a limit approaching a certain number. Because remember, these are just estimations, right? There's a hole there, so technically 4 is not actually a thing, but it's just an estimation here. However, here is quite literal. So then let's take example E. Well, example E approaches 0 from the left, so we're looking at 0 over here from the left. So it would be this one, actually. And it would be equal to 1. And the reason why it's this line and not this line is because technically at this point, this would be the right side of it and this would be the left side of it. So you have to consider the sides. Don't get tripped up on the way the graph is looking. And then over here, the answer would be -1, because now it wants you to consider from the right side because of the positive sign here. And of course, it's -1 at this point where it's 0 at x. And as we go down, it wants you to know at 0, well, there's a gap here, so technically both limits don't actually approach 0, and so the answer does not exist. And here it wants you to evaluate h at 0. So we look at 0 again, and we see that this is a hole, but here it's shaded in. If you can't see it, I'll erase it. Here it's shaded in. Well, here's a hole. So the answer to this one would be 1 because it's the part where it's shaded in. Then we go down here. It wants us to evaluate for 2. The answer would be 2. The reason why is because, again, look, 2 matches right here. And then h of 2, the answer is does not exist because there's a hole. Remember, if it gives you a question that doesn't have a limit, just this, it's usually doesn't exist if there's like a hole at the point. If there's a closed point, then it will exist. And this one's asking for 5 from the right and 5 from the left. Let me look up here. Let's look at 5. Let's first look at from the right. From the right, we can see that the point would be right here, which is 3. So from the right, it would equal 3. However, from the left, it's different because if you notice, there's a bunch of oscillations here on the graph. And so even though it looks like it would eventually end at this exact point, if you ever see something like this where there's just like a bunch of shading, it actually means that it does not exist. Because it doesn't actually, it's like approaching it, but it doesn't, you can't actually tell, you know, no matter how you zoom in. So in a test, it would not exist.